Alrighty, to conclude chapter 3, we're going to look at 3.4, exploratory data analysis. So our fourth objective here is to use the techniques of exploratory data analysis, including box plots, 5-number summaries, to discover various aspects of the data. So a 5-number summary and box plots include 5 specific values. 1, the minimum value of the data set. Whatever the smallest data value is, you need that. 2, quartile 1. 3, quartile 2, also known as the median. 4, quartile 3. And then 5, the maximum value of the data set. This information will help us produce our 5-number summary to produce a box plot. So a box plot is a graphical representation of the data set. To construct a box plot, we're going to find the 5-number summary, which is what we just talked about. Then we're going to draw a horizontal axis and place the scale on the axis, whatever the numbers go by. The scale should start on or below the minimum data value and end on or above the maximum data value. Locate and mark each of the values of the 5-number summary. Then draw a box with vertical sides through Q1 and Q3. Then we're going to draw a vertical line through the median. And then finally, we're going to draw horizontal lines to the minimum data value to the left box and draw the line to the maximum data value on the right side. And really what it should add in here as well within the upper and lower outlier boundaries. And just a little extra note here, we will denote outliers with an asterisk. Then the whisker will fall to the next number. I don't think you deal with it so much in this statistics, but in your next statistic course, to give you an idea, this is what we're going to draw. This right here represents your Q1. This right here represents Q3. This right here will represent Q2 or the median. We'll draw a box around that. This will represent the minimum. So this is what we call a little whisker. This will represent the maximum. So right here, this is not uniform. This could be very skewed in any direction depending on the data. But if there was an outlier, let's say this was, I don't know, let's go with the other one. That max was 54 on the last video, sorry. The max was 54 and we had an outlier 52. The next number up would have been 32. So what you would have done is the max would have been 32 here, and at 54, we would have had a little asterisk there. So our box and whisker are there, but then that asterisk would represent, hey, this is an outlier that we're kind of taking out of the data set so it doesn't skew what we have here. Again, remember our Q1, Q2, and Q3 is not affected by the outlier, but your min and max are. So we can bring that whisker back in to make it not look so drawn out for that whisker. And again, I don't recall if they go over this in the statistics or not, but if we do not end up with that situation, I want to make sure you have that information. It's always good to have. All right, so that's just my little tidbit there to add into your notes. So information obtained from a box plot. So A, if the median is near the center of the box, the distribution is approximately symmetric. So what I just drew would have been approximately symmetric. If the median is to the left of the center of the box, the distribution is positively skewed, meaning, so again, if this is the median, a little rough drawing there. So if the median is to the left of the center of the box, the distribution will be positively skewed. If we have something that looks like this, So the meaning is to the right of the center of the box, the distribution will be negatively skewed. So just looking at a box and whisker plot, I can then tell you what a bar graph would look at as well. 2, if the lines from the box to the minimum and maximum are about the same length, the distribution is symmetric. So you can see those whiskers are about the same. If the box from the minimum is longer than the line from the box to the maximum, the distribution will be positively skewed, meaning if I have something like this, just random, but then my max is like that, I can see it's going to be positively skewed because the information is being pulled to the left. If the line from the box to the minimum is shorter than the line from the box to the maximum, the distribution is now negatively skewed, meaning if I have something like this, now my data is being pulled to the right, so now it will be a negatively skewed data. All right, so those are some rough drawings. So let's look at an example here. So in example 22, we're going to find the 5-number summary, and we're going to construct a box plot with that information. All right, so for the given data from example 17, we're going to find the 5-number summary and then construct a box plot. So here is the data. So the first thing we want to do is we want to arrange the data in order. So this looks like a 12, 13, 15, 16, 18, 19, 20, 27, and 36. Now we're going to find the quartiles. So we're going to start with the maximum. So the maximum value here was 36. Q1, oh, it's easier to find the median. So let's do that first. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 tells me I need to go to the 5th number because 9 divided by 2 is 4.5. So 1, 2, 3, 4, 5. This will be the middle number. So then the middle of those middle numbers would be here. So that'd be 14. Then we need our Q3. So in between these two numbers, I believe was 23.5. And then the max, I don't know if they have, I think this right here is supposed to be median, or not median, middle, or minimum. Minimum, which was 12. Max would be 36. So there is your 5-number summary. Right? We're going to use that information and see if I can easily kind of bring this down. Okay, so, gosh, I need this. Maybe. Yes, I can do something like this. All right, so I'm going to erase this part, these parts right here. I want to try to keep this. This was my Q1. This was Q2 right here, Q3. Okay. One thing I do need to check. Let's find IQR. I know it doesn't tell you to, but I think it's a really good idea. So that's going to be Q3 minus Q1, which is 23.5 minus 14. So 23.5 minus 14 is 9.5. So now I just want to find my upper and lower boundaries. So my lower boundaries of outliers would be Q1 minus 1.5 IQR. So in this example, this would be 14 minus 1.5 of 9.5. So multiply that by 1.5. Oh, didn't type it. Multiply that answer by 1.5. I get 14.25. So 14 minus that would give me negative 0.25. And then my upper would be Q3 plus 1.5 IQR. So in this example, this would be 23.5 plus 14.25. So if I come over here, I'm just going to add 23.5 to that, and I get 37.75. My max was 36, so it does fall within the boundary, but it's always good to check that. So If it ends up being an outlier, we can use the asterisk. I don't have any negative numbers, so I don't have any lower boundaries. All right, so I just wanted to check that. It doesn't illustrate that in your notes, and it just bugs me. But you definitely need to make sure you check that because you could end up with that situation. All right, here's a horizontal line. Let's pretend that's straight. Again, you want to start or below the minimum. The minimum was 12, so I'm going to go with 11. And then I'm just going to go by ones. So 11, oh, the highest number is 36. I'm going to go by, I'm going to start off at 10. I'm going to go by twos. So 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, and 36. And we'll do 38 to kind of catch that up. All right, here we go. So we start off with, I like to start with my Q1, which is 14. So I'll draw a line at 14. My Q3 was 23 and a half. So here's 23. 23 and a half will be roughly about right here. So I'll make a box. I'll then go to my Q2, which was 18. So that's about right here. I then go to my minimum, which was 12. I'll put a line here. This is my first whisker. And then I'll go to my max, which was 36. So there is my box plot. So there you go. You just built your first box plot. And because of that max being pulled so far to the right, I can definitely say this is going to be right skewed or negatively skewed. All right, so with that said, I don't want to erase that. I'm going to erase this part, though, all my work. You should have that already, but I want to use that box plot that we have here to answer the following question so that we can analyze it and see it. Let's see if oh, okay, that works. All right, so the box plot from example 22, again, has a shorter line on the left than on the right, and the median, it's hard to tell, but it is a little to the left of the center. Very, very small detail. You can almost argue maybe it's not. Left of the center of the box, so the distribution appears to be right skewed. Now, I went with right skewed mainly because I could see that the data was being pulled to the right from that 36 itself, which then because the thing was on the left and most of the data is on the right, I can see it's being pulled. All right, so there you go. So that is a box plot, and that will wrap up chapter 3. As always, if you ever need any more examples or help through the homework or understand anything, please reach out and let me know. Until the next video.